This is part one of the Earth's atmosphere topic. It's GCSE AQA chemistry, and this is for dual and triple award students. So anybody taking AQA GCSE chemistry will need to cover this work. In this topic, we're going to start by looking at the history of our atmosphere, and I'm going to recommend that you pause and have a go at the activities as you go. So we need to discuss theories of how our atmosphere developed to become what it is today. And we also need to be able to interpret evidence and evaluate different theories when information is provided. So let's jump straight in, have a read through, and there's a question at the bottom. So we're saying that the Earth is around 4.6 billion years old, initially a ball of molten rock. It cooled. We then got a thin crust on the surface of it as it solidified, but volcanoes regularly allowed lava to break through. There were constant eruptions, and as they erupted, they threw huge amounts of gases out into the beyond the planet, and that was essentially where the atmosphere came from. It was a barren rock. There was no life. And so we have to really think carefully about how we can be confident with this and where we got this information from. Why is it difficult to be certain about the gases in the early atmosphere? Well, it's a really straightforward answer to what might feel like quite a big question. Nobody was there to see it. There was nobody there to record any evidence. So we can only theorize. We can only make assumptions based on what we do know and the science that we do understand about what it used to be like. Now we're going to focus much of this video on the first theory, the main theory that people subscribe to. So again, read through and answer the questions as you go. So we've got here carbon dioxide, water vapour and ammonia all released by the volcanoes erupting on the surface of that newly formed Earth. The Earth then cooled, oceans formed, and we may also have had water brought to the planet by comets that were striking it. So what do we think? What were the formulae of the compounds named above? Now everything in there actually is a compound. We've got carbon dioxide, we've got water, and we've got ammonia. All hopefully quite straightforward, fairly familiar. Certainly the first two. Carbon dioxide is CO2, water vapour H2O, ammonia, one that does come up a lot across the GCSE course and that you do need to be familiar with, is NH3. What change in condition would have led to the formation of the oceans then? Well, there's a big clue in what we have on here as the Earth cooled. So as the Earth cooled, there was lots of water vapour in the atmosphere. As the water vapour cooled, what did it do? It condensed. It would then precipitate, fall as rain, and it would then start to fill those valleys on the uneven Earth's crust to give us the oceans. Okay, read and have a go at these questions. So the Earth did cool, it stabilised. We then had a huge amount of carbon dioxide, maybe small amounts of water, small amounts of methane, and there would have been virtually no oxygen. And at that point, it stayed that way for a long, long time. We then, however, got bacterial life, followed by plant life and algae. Thinking about these questions, chemical formulae of methane and ammonia. Well, ammonia we've actually just spoken about, so hopefully you remember that's NH3. Methane is another formula you need to be very familiar with, and that's CH4. In the crude oil topic, you learn about methane, ethane, propane, and butane. So there is crossover there. Okay, what about the equation for photosynthesis? So it is linked to biology, but you do need to know it in chemistry as well. Well, CO2 and H2O are the things that plants take in, and we know that they make glucose. You need to know the formula of glucose is C6H12O6. We also know that photosynthesis produces oxygen. We rely on that. Plants provide the oxygen that we go on to breathe. And oxygen, we remember, is diatomic. It exists in pairs. What I then need to do is balance it, and I'm going to start by balancing my carbons. I use the rule of Cho. I spoke about that when we were balancing the combustion of hydrocarbons. Worked well to do the same thing here. So balance the carbon, 6 CO2 because I've got C6. After the carbon, balance the hydrogen, that's C H. I've got 12 hydrogens on the right, so I need 6 H2O on the left. Finally, I balance the oxygens. So I've now got 6 times 2, 12, plus another 6. I've got 18 oxygens on the left. 6 of them are in the glucose. That means there's 12 left, which means I need 6 O2. So have a think about the top question. How can we use the information that we've just provided to explain how oxygen began to form in the atmosphere as the first forms of life began to evolve? Well, we just said that the first forms of life were bacteria, algae, and plants. We know that plants photosynthesize. We know they produce oxygen, so that oxygen started to be spread out and diffused through the atmosphere. As oxygen levels increased, it became possible for animals to evolve. They could not make their own food. So on these questions, what's the equation for respiration? Well, for respiration, we take in glucose and we react it with the oxygen that we inhale, and we make carbon dioxide and we make water vapour. So C6H12O6 plus 6O2 goes to 6CO2 and 6H2O. And what you are hopefully recognising here is that that is exactly the reverse of photosynthesis. It is actually a reversible reaction. It can go in both directions. And that fits in with the previous chapter where we looked at reversible reactions. So plants make their food, they make glucose. Where did the food for animals come from? Because animals don't photosynthesize. The animals ate the plants. That was it. Finishing off theory 1, many of the earliest microorganisms could then no longer survive. The oxygen was essentially toxic to them. We obviously rely on it, but they could not survive. Now that's the end of theory 1. You need to be prepared to write at least a very brief summary of those steps. You need to be familiar with the points that we've just spoken through. Going to finish off by looking at an alternative theory. It might be solar debris crashing into the Earth. In this particular sort of question, you're likely to be provided with information that you can analyse. You will make evaluative comments based on what is given in the exam. So make yourself aware that there are different theories, make yourself generally aware of what they are, and be prepared to use data provided when you get into the exam. That takes us to the end of part 1. Thank you for listening, and goodbye.